Welcome back to Let Us Learn to Lead video series on free open source software designed by M. Srinivasan, Training Associate Mathematics, Kendriya Vidyalaya Sangathan, Zonal Institute of Education and Training, Mumbai. Self-learning contents in video form on GeoGebra dynamic mathematics software is presented at this video series. To view the contents, you may join Google Classroom by using the class code 73AUMBO. In this video, you will learn designing worksheet to check properties of tangents from an external point to a circle. For preparing this video lecture, I used Windows 10 operating system, a licensed version, GeoGebra 5.0, a free open source software, and free open source screen recorder software. Let us start. Let me show you what type of worksheet we will be designing. We will be telling the children first that no tangent can be drawn when it passes, which passes through a point lying inside the circle. And we will take one point inside a circle and tell that there is no tangent, but there is only one point there, and which lies on a circle single point, there is a single tangent. Suppose we are having a point outside. There are exactly two tangents, we are showing them. Okay, now the child can pull and push it and then check out about the two tangents. The two tangents, they can move it also here and there, and they can change the radius also. Okay, the radius also they can expand and then check whether there is only two tangents or there. Now the property is actually the length of the tangents is equal. Therefore, whenever you move anywhere, you move it here or move it there, everywhere, the length of the tangent from an external point are always equal. Let us try to design this dynamic worksheet from scratch. For that, I have taken GeoGebra Classic 5 worksheet, geometry view. In the options, I have taken labeling of new points and rounding off to 1 decimal place. Let us try to start with the heading for this particular worksheet. Tangents from an external point to a circle. Okay. And you can tell the statements one after the other. No tangent can be drawn which passes through a point lying inside. That you can make the statement and you can ask the children to explore it. And for that, as usual, I will take a slider with integer from 1 to 10 and with increment 1, and there is no need for it, it is left to you. Okay, now I will go for one circle now, circle with the center and radius. Let me go for it. Radius I will keep it as n. Okay, now I will make it little bit big. N is equal to 2. The first statement is no tangent can be drawn. Therefore, take a point, put it inside. Okay, now you can tell that inside the point is inside. Therefore, you cannot draw a tangent. Okay, now let us go to the next statement. There is only one tangent which for a point which lies on the circle. Therefore, for that we make the statement. Now the children to come and check it out. And how to check it out? Very simple. Make it little bit big. Take a point on the object. It may be point C or whatever may be. And you go to this tangents. It is in the perpendicular line. The tangents. What you have to do? You have to touch this point C and touch this point, the circle. You got a tangent. But now you can tell the children that there is only the C is actually moving. Then you are seeing that there is only one tangent. Okay, now let us go to the next statement. Suppose if there are exactly two tangents will be there for a point lying outside. We will make the statement and we will take a point outside. It is left to you. You can rename the points also. This center can be renamed as O and so on. It is left to you. Okay, take a point outside. Normally, if you want, you can rename it as P. Normally it will be taken as P, a point outside. Okay, well, now we want to just tell that you can draw only two tangents from it. Okay, how to do it? Go for this tangents. It is under perpendicular line. What it tells, you have to touch the point and then the circle. Therefore, touch this point and touch this circle. Oh, fantastic. There are only two tangents you are getting. Let us go and have the point of intersection of this tangent and this circle, this tangent and this circle. Good. Therefore, now you have shown that. Now, if you want to show it as a segment, it is also possible. PD, you make a segment, and PE, you make another segment, and this remaining big lines, you can show the object, and again right click and show the object. Okay, well, now you have got a PE. I'm doing escape. PE, escape, or this arrow you can move also, you can click it. Okay, now you see, well, there are only two tangents everywhere. Whenever I'm moving it here, and all, I'm having only two tangents now. If you want to show it in a different color, you can right click it, segment PE, object property. You can go for its color as a red color or whatever, maybe a better color you can choose. And in the style, you can have the thickness up to 9 points, and you can click OK. Similarly, this can be selected, segment PD can be selected. Once again, thickness 9 and the color, the same color if you keep, that will be better. Okay, well, now what is the next statement you want to make? The length of the tangents from the external point are always equal. We will make the statement now. We'll go for this ABC and make the statement. Okay, now we have to measure it. For that, as usual, go to this right click, go to the object property. In the basic, you can have this name and value. Again, click it, right click it, go to the object properties, segment is selected, go and go for its name and value. Okay, they are all I and J. Okay, you can keep this J outside. Okay, now you can pull and push, you see always they are equal. Okay, when you increase the radius also, it is happening the same thing. You can make the statement over here, that is PE is equal to PD is equal to, from the object property, either you select I or J, both are one and the same, is equal. Okay, now a child can come and check out whether it is always equal at all the spots. They can move it. They can't move D and E. They can make the circle big, they can make the circle small, and so on. For here, they have understood that tangents, no tangent if a point lying inside, only one tangent if the point lies on the circumference, and there are exactly two tangents when the point lies outside. Not only that, the length of the tangent from an external point of the circle is always equal. Thank you. Let us learn to lead.